Okay, guys, so we're just going to go through some of the R code now for this week. We're not going to, again, because of the interruption, I'll probably teach a little bit more next Tuesday's class than I would have done otherwise, because there's a few things I want to go through in person that you'll have a chance to ask questions. But I just want to get going a little bit with the code and some of this code. So again, make sure we're set. This is the directory on your computer that should have we should have got this all sorted out, which has your code files. You need this file, BQ Analytics Week 4, and you also need cardata.csv. There are a few other files which are to do with the exercises, but for this little demo, you need car data. So let's set this working directory, and let's read in the data. Now, if you recall view, we have, and this is a really simple data set. We have some perceptions. I think this is gathered from MBA students. We have these different brands of cars, and I guess this is an average value. They rated it on how luxurious they are. So we range from Mercedes is a 5 to Chrysler is a 1. How safe they are, Volvo is the safest. How sporty they are, BMW and I wouldn't call it BMW too sporty, but BMW and Volvo get 5 and Chrysler and Volvo get 1, etc. Then we have family, practical, and exciting. Okay, so that's our data. It's all numeric data. So the first little thing we do, and this just sometimes makes it, we don't need, makes it easy for us, is attach. So I'm going to do attach car data. This just means we can directly access things like exciting. So rather than typing in car data dot exciting, we can just type in exciting, or we can type in luxury. Okay, so what we're going to do is we're going to actually do some plots. And what we're going to do is, in the little business example, I said, hey, we can only show 2 segmentation bases. So we're going to plot kind of multiple plots of segmentation bases. Par MF row equals C2, comma 2. And all this is a way of R just splitting up the plotting screen. Par is just the command to the graphics. And MF row just means we're splitting it into rows and columns. And C2, comma 2, this is just the number of rows and the number of columns. And then this just means that rather than when you do a new plot, rather than replacing the plot, it will go to the next quarter of the screen. So we'll do this par MF row. And then we can plot things like, here we're going to plot exciting versus safety. And we're going to give it a title, exciting versus safety. PCH, this is just the shape that we're going to plot. And we're going to put X on the x-axis. We're going to put exciting on the x-axis and safety on the y-axis. And we're going to repeat it for 4 different plots. So you can see this is not particularly nice. So I'm going to do a better version with ggplot. And I'm going to use an extra package called gggrepl. You should have got this by now, but all this code is saying that is if we don't already have ggplot2 installed, then we install it. And this just loads it into memory so we can use that function. So we're going to create 4 different plots. Each time, remember, with ggplot, you pass it the data, you pass it the AES, which is the information you're going to use. So we'll use X for exciting, Y for safety. And then we're going to run GOnPoint for plotting the point. So it's exactly as we did in week 2. And then we're going to use this extra package, geonLabel_repel. And the only difference in this between a standard label is we don't plot the labels on top of each other. Because you can see here we had 2 cars on top of each other. It was a bit of a mess. This prevents that. And if things weren't complicated enough, let's just clear our graphics area. So if you do dev.off, that always clears your graphics area for you. So we've got our 4 plots here, we're going to create our 4 plots. Now, with ggplot, rather than just to be complicated, rather than using par MF row, we've got a different way of arranging 4 plots. And this time we use the grid.arrange function from grid extra. And we basically say we're going to put plots 1, 2, 3, and 4. And we're going to have 2 columns. So 2 by 2 is 4. And there we go. We get these 4 plots. So you can see here, if we plot practical versus sporty, we have Chrysler, Ford, and Volvo, all very practical, but not very sporty. And you can see BMW are very sporty, but not particularly practical. Exciting versus safety. Volvo is just not exciting, but it's very safe. Porsche is very exciting, but it's not very safe. And that's perceptions. Maybe Porsches are quite safe, but people don't think they're safe because people drive them at high speeds. And again, family versus luxury. We've got Chrysler, Volvo, and Ford at the top. Low luxury, high family. And then we have the more luxury end, we've got Lexus and Mercedes, pretty much at the same. BMW, Porsche. And then we got like Saab and Jeep in the middle. Okay, so you can see the problem here. We've got like lots of different plots, and if we have, we only have 6 possible data dimensions here. And if you go back to your high school math, oh, here we go. This is the one we want. Let's get rid of our. Oh, let's just move it. Okay, so I realized just move it like this. Go back to the pen. So if we have 6 dimensions, so we have 6. Let me just get my pen. Then we have, and don't worry, I'm not going to set this on the exam, but a bit of your middle school math or high school math, permutations and combinations, 6C2. And it's basically going to be equal to, remember this. We've got and I'll write out the formula if you don't remember it. This is just the way of taking how many ways we can take 2 items from 6. So how many of these 2-dimensional scatter plots we can take out from 6. And this is like 4 factorial is like 4 times 3 times 2 times 1. So let me just get back to my pen. We could just basically 4 factorial. We could cross it out, 4 times 3 times 2 times 1. And this is going to be 6 times 5 times 4 times 3 times 2 times 1. So it's just kind of 6 times 5 times 4 factorial times 2 factorial, which is basically 2 times 1. And so we get 30 over 2, which is 15. So even with this very small amount of data, we had 15 different possible scatter plots, which is a very big number of, if I was to show 15 scatter plots to my manager and say, this is how our brands compete, then they're going to go a little bit cross-eyed and ask me what I'm doing. So what principal components analysis does is it basically now, if I was teaching this in a PhD class, I would be talking more about we're trying to get the maximal variance of the original dimensions into the new dimensions. But all I will say for this class is we've got 6 pieces of information. We're trying to squeeze as much as possible of the variation in that data. So rather than maximal variance, we think about squeezing and squashing of that data into the actual graph. And we do this, let's just reset the graphics environment again. We do this by using the prcomp function. Again, I would always ask you when you see something you don't understand in my code, just do a question mark. And this will tell you all about the prcomp function. We're going to pass it the car data. Now the car data, if we look, the first column is the brand. We could also do str. car data. So the first column is the brand. And we can't do principal components analysis on the brand because it's not a number. So we're just going to do, all this means is I'm doing columns 2 to 7. I'm going to scale that. We don't need this data all on the same scale, but generally, if, for example, I was doing an analysis where I had one dimension was, average time a week we go shopping, and the other was your income in dollars, then if we didn't do this, then the income in dollars would actually kind of dominate the times of week shopping. This is just kind of to scale the variables. And ask what do we get back? So in R, if we have an object and we want to know what's in it, we just type in names. So we get the standard deviation, we get the rotation, we get the center, the scale, and the X. Now I'll go through a few of the most important things. The X is basically these new dimensions. So I'm going to see what do we have in the X. We have what we call the principal components. Now, as I said, at each stage, we're trying to maximize the amount of information we squash in these. So we're going to take the first two. So this is the most amount, basically the most amount of information we can put into 2 dimensions. And I'm going to plot it. Now, all I'm doing here with new config, this seems a bit fancy, but cbind, if you remember, we did the bind functions, I think, in week 1. This is just combining columns. So we have our car data, the first column, which is just the names, with the results, which I've just shown you, the principal components. And we're basically making sure that everything's a data frame. So we're going to do new config here. And we can see here that we've got our brand. We've got the PC1, we've got the PC2, we've got the PC3, we've got the PC4, we've got the PC5, we've got the PC6. Let's just kind of run this. And we can see here, we can see this new map that Mercedes and Lexus are competing very closely with each other. They're in the mid in PC1 and high in PC2. We can see that Ford and Chrysler are competing with each other. Volvo is a little bit on its own. We can see Porsche and BMW are competing, but not too closely. Jeep is somewhere between this mid-market of Saab and Infiniti and Ford and Chrysler. Okay. So let's do a few of the things. We're going to use a library called FactoExtra. And what we're going to do is we're going to plot something called, we're going to plot the eigenvalues. Now this is, again, this class, I really can't do matrix algebra in a business school, but this is just the amount, and I'm not going to ask you to be able to code this, just this would be a case of having to copy and paste my code without 100% understanding the math. But here you can see we get what's called an elbow plot or a scree plot. And this is just the amount of variance or information from the original data in the new kind of data components. So we can see here that the first component had nearly 70% of the variation of the data, and the second one has nearly 20%. So we can see that that graph I just showed you had almost 90% of the variation in the original data. We can also get some other information. I don't think this is too useful, but this just shows the means of the original variables, the center. And the next thing we get are the loadings. Again, I'm doing a little bit of matrix algebra here, so you're just going to have to roll with me. And all I'm doing is we have something called the rotation matrix. And all I'm doing is here to make sure that I'm normalizing it for the amount of standard deviation. Again, I would never expect you to recreate that in an exam. This is just a case of copying and pasting my code and understand it. But in PCA, what the loadings do is these are basically correlations between the new dimensions and the original variables. So quite often what we do that is that this is a mixture of art and science when we do segmentation, is we want to name our new dimensions. So this is my first dimension. This is my PC1. And you can see that it's positive on family and practical, negative on sporty, negative on luxury, and then kind of moderate on safety. So I'm going to call this my, you know, I don't I want to use a new name, but maybe I'll call it my stay dimension or my family practical dimension, as those are the two highest loaded. Um, my kind of average family dimension, whatever. And the second one's a little bit harder, but we can see the only one highly loaded is safety. So we'll maybe call this my safety luxury dimension, or just the high-end safety dimension, we'll call this. And again, let's just go back with this new information. And you can see that all these are pretty kind of well-appointed safe cars. But we can see to the right where most of the variation is. This is the best dimension. We go from the family-oriented Volvo, Chrysler, Ford, Jeep, through to the least family-oriented car, which was the Porsche. Now, the next little thing I'll show you is what we call a biplot. And what a biplot does is it basically relates, again, this is a little bit of interpretation, but it relates the brands, it relates the new dimensions to the original dimensions. And so you can see here that family is highly loaded on the first principal component, same with practical. Safety is very highly loaded in the second principal component. Um, Luxury is slightly negative on the first, positive in the second. And we can actually see where our brands are relative to the original dimensions. So you can see that Ford and Chrysler are on high on practical. Volvo is closest to family. Exciting Porsche, BMW. So this is just a little map. It shows us basically where our products are, both on our new dimensions, but also relative to the original pieces of information. So again, if I was looking at which brands were competing and I wanted to make a marketing proposition, so I say, hey, my Mercedes, it's a luxury but safe car. It's competing closely with the Lexus. This kind of puts everything on one map. Okay, so the last little thing, and I think I put on the revision guide, this is definitely not on the exam, and this is basically rotation. Now, all rotation is doing is it's basically doing a rotation. It's turning the solution around until you get the best possible loadings. The idea about these loadings is they should be pretty much high. They should be either high or low or zero. They should be like -1 or 1 or 0 in order for you to be able to interpret them properly. So let's just run. This is what's called a varimax rotation. Again, I don't want to put matrix rotation in the business school class, so this is strictly off the exam. And you get these new loadings, and you can see here that safety now has a 0 on the first dimension. We don't worry about safety in the first dimension. And the second one really is just a safety dimension. This is the only thing kind of rotated high on it now. The rest is pretty much similar. You can see family and practical are high on the first dimensional principal component. Sporty is low, luxury is low, exciting is low. And then I basically all this is doing the rotation, and we can look at the rotated solution. Oh, and then we do exactly as before, and we actually plot the rotated solution. And you can see here now in this pure family dimension, Chrysler, Ford. Chrysler is the most family oriented, then Ford, followed by Jeep. These are further down. And in the safety dimension, Volvo is by quite a way the highest, then Mercedes and Lexus, these well-appointed mid-end luxury cars. And again, this is all perceptions. You could argue the Porsche probably has good safety features, but consumer perceptions are that the Porsche is not a safe car because people drive it too fast. Ignore that. That was just me being fancy with some more rotations. And then there's actually a different way. This was principal components analysis. We can also do something called multidimensional scaling. And this you basically just uses distances. So it looks for the distances in the six original. I'll show you this on the board next class. In the six original dimensions, then tries to recreate them as much as possible on the new kind of two-dimensional map. This is probably best if I show it you on the board. I can show it you using some simple diagrams and Pythagoras, but just think at the moment it's just an extra method of data reduction. We use a library called Smakov. We create our distances. We run a Smakov function, and it's loading lots of packages in. I'll just pause it. Nope, here we go. So basically, we run this function Smakov. We just we create our distances. We run the function. We have to this time we have to tell it what our output dimensions are. So we have two output dimensions, and again we can do what we did before. We do MDS out, and I give you the configuration. And this is basically just the new solution in 2 dimensions. And then we can plot this new solution. So this is just a different method doing the same thing. You can see that the dimensions are all swapped around here. There's not the same ordering. But here you can see we've got Chrysler, Ford, and Jeep are still close together. Porsche and BMW, Mercedes, Lexus, and Infiniti, and Volvo is down here. Now, what I might actually do is it doesn't matter which way round you are. I might flip these around a little bit because if I think this is probably going to be a relatively safety dimension, but Volvo is low on it, so this is almost like negative safety. So I would probably flip this around a little bit. And again, we can also do the same as before. We can calculate the loadings, but in a slightly different way. And you see this dimension 1, you see it's kind of negative on safety, it's negative on family, it's negative on practical, but it's high on sporty and it's high on exciting. So I would call this maybe my vroom dimension, my high-end sporty dimension. And dimension 2 is kind of, it's not quite as strong, but you can see it's positive on practical and exciting, but negative on safety and luxury. Though I don't think this is kind of like quite as strong as the first method, the first graph. Okay, so we went through just an idea of all we're doing is we're taking like 6 pieces of data, we're squashing them into 2. So we've not got all these like 15 different scatter plots. And then we're making a little bit of inference. You know, which brands are competing with each other? How do we relate these new dimensions to the original dimensions? And again, I'll give you a little bit more conceptually on the board next Tuesday, but I just wanted to introduce the method.